What's up, everyone? How's it going? Happy Tuesday. Just before we get into it, can everyone let me know, can you see me okay? Can you hear me okay? And most importantly, can you see Cinema 4D? I hope you're all doing well. I hope you're all good. I'm ready to learn some, hopefully, some cool stuff. As Shafi said, hopefully it's going to be awesome. Yeah. So yeah, just let me know if you can hear me all good. And then we can get going. All good. Thanks for the thumbs up, MG. Appreciate it. Cool. Hey, Igor, how's it going? All right, cool. So let's get into what we're going to be doing. So today, the plan for today is actually to go through quite a few different things inside of Cinema 4D specifically. So I put together this waffles and syrup scene mainly because I wanted to play around with some liquid tests. And full disclaimer, we can't really do liquids that well inside of Cinema 4D, mainly because we don't have a liquid or like a powerful particle system. So I wanted to see what kind of fun techniques I could do to find some potentially more stylized effects, as well as finding some things that we can animate as well, especially looking at the new simulation settings and things like that. So here's just a quick little animation that I created just for you all to see, an idea of the types of things we can cover. Let's play it through again. So yeah, it's not too bad. Like it's not too bad. And that's kind of like my disclaimer. So yeah, the plan is we're going to model the waffles. We're going to do this in a procedural way. And I'm going to talk through why it's beneficial to create them procedurally, and we can see some benefits to that. We're then going to create a soft body simulation of our waffles sort of coming down and piling on top of each other. So if I just show you like a still shot that I did, which is a slightly different version. So we can see here that they're all piled up on top of each other, and we have a little bit of bendiness and softness going on. So these techniques are going to be good for whether you want to do stills or animations. And we'll talk about the two different sides of things. And yes, they're making me hungry as well. I don't know why I thought this was a good idea. Embracing my inner Patrick 4D, who's an amazing ZBrush, C4D and Octane artist. Yeah, so then we'll do the soft body sim. We'll then look at baking these things as alembics. So we're going to cache this data. And then we're going to dive into the liquid syrup tests. And this is going to use a whole variety of different tips and tricks inside of Cinema. But the thing is, depending on the timing of that, because I don't like to run much longer than sort of like the 90-minute mark, we may not get to the Redshift side of things. But don't worry. If we don't, it's not going to necessarily be a problem. I can always do another stream where we dive into that. But I've also got some links which go through some cool lighting techniques from the past couple of weeks with Dustin, myself, and Ian. And I've also got a stream I did a couple of months ago on how to create these procedural textures, and it's exactly the same way. So it's not going to be the end of the world if we don't get to that. I'm also going to supply a full project file, including the lighting and the texturing and my render settings. And I'm going to do that maybe by, let's commit to Thursday or Friday, because I need to change I've got some resources in there that I can't share. So some like textures, and I don't think I can share the HDRI, but don't worry, I'll do some good replacements for you, I promise. Cool, so let's get into it. And the only other thing I would say is if you have any questions for me, that's cool. I'm going to keep an eye on the chat, but because it's just me here, if you could do me a little favor, if you do have a question specific to what we're talking about, just add the word question at the beginning in capitals as well, would be great, because then I can just flick through, find the questions, and we can talk about them without me sort of having to deep dive into all of your lovely conversation. Cool, so let's get into creating this procedural waffle, and it's super simple. We're basically going to be using a bunch of primitive shapes and some deformers. So we have our primitive shapes can be found in here, and then our deformers can be found in here, and then we're going to throw everything together in a volume builder because we're not too worried about how our topology looks, because we can fix that. We can fix it later on. So let's just grab ourselves a cube. And what I'm actually going to do is, I don't like working with the work plane, so I just like to switch this off, just so we've got a good starting point. So yeah, this is going to be the base shape of our cube. And I'm actually also, normally what I do is I work with a reference image, but for now I'm just going to keep my own image as a reference. But I find that is really beneficial, not only when it comes to texturing, like I definitely like using reference images when I texture, but also when it comes to modeling, just so you can get an idea of the rough shape. So what we're going to do, we're going to create this in a real world-ish scale. And so let's just make that 10 by 1.5 by 10. And the reason we're going to go with a real world scale is because this is going to help when it comes to adding our lighting and our cameras and our textures later on. But there's some things we will need to do, some tricks we'll need to do when it comes to simulating to make sure that we tell Cinema 4D that we're working with small scale objects and elements. So this is the kind of sizing that we want to go with. And let's just create another cube. And so we're going to create those little gaps that we have in between the waffle, you know, the little markings that come in between. So let's do that. Let's just make that. What do we want to do? Maybe one. Let's do 1 by 1 by 1. Again, because it's going to be procedural, it's totally fine. We can change all of this stuff throughout. So let's drop it into a cloner just so we can get that nice grid of those indentations. And I've just changed this to endpoint. And so what this means is the entire distance that this grid is going to make up is going to be whatever I put the endpoint at. So let's try something like 8. And then we're going to try something like 8. And let's just pull this up so we can see what's going on. Now, as I start to add the rest of my cubes, we can see that we are creating a 5 by 5 grid with a distance of 8 by 8. And what I might do actually, let's make these a little bit bigger. And let's take a little look at the top and just see where we're at. All right, cool. That's fine. Yeah, that's fine. I'm happy with that. Again, we're not going to be working in a destructive way. So at any point, we're going to be able to change any of this, which is going to be great, especially during the modeling side of things. All right, cool. So let's actually just get rid of my clone now, because what I'm going to do, I'm going to add, this is when we're going to start playing with our deformers. And I'm going to make it so this cube, which is going to create that indentation, that little kind of like that gap or that hole in our waffle, I'm going to make it so it tapers inwards. So we have a bigger area at the top and a smaller area at the bottom. So the way that we can do that is inside of this menu here, we have our different deformers to do a variety of different things. What we want is we want the taper. And so we've got large icons. And I'm going to make it a child of my cube. At the moment, it's very big. But a little trick that we can do is we can hit this fit to parent option, and it's just going to resize it to the parent object, which in our case is the cube. Let's go fit to parent. And if I come a little bit closer, you can probably see it a little bit better. So now we have this bounding box surrounding my cube. But it's actually the wrong way around. So at the moment, we can see we have these arrows at the top. This is implying that as I adjust my strength, it's going to be just doing the top section. So what I actually want to do, I want to flip it around. So I'm just going to change the alignment, and I'm going to go fit to parent again. Perfect. So the thing is, we're not actually getting what we want. Well, it is tapering in. However, because on our cube, we don't have a lot of segments. Think of your segments as your subdivisions. And if I press NB, you should be able to see the segments that are making up our cube. At the moment, we've just got n-gons. And so we can't actually deform or change the shape of these. We need some more segments. So if I just increase my segment amount here, we can now see that we're getting some nice curvature on here. And now as I adjust my tape a little bit more, it's working much better than it was at the beginning. Oh, so if I switch back on my cloner, it will clone those cubes with that taper on. So I haven't had to do anything special to do that, just enabled the cloner again. And then if we want, we can duplicate this cloner because we want the holes to be on the other side. But a little trick, instead of having to worry about that, is we can just grab a symmetry. And if you hold down the Option key, it will throw it straight into the symmetry. But if not, just drag and drop and make sure that your order is the symmetry, the cloner, then the cube, and then the taper. And we can see the plane of our symmetry. And so at the moment we have symmetry on the x-axis, but actually we want it on the y-axis because we want it on the top and we want it on the bottom. So what I'm going to do is I'm going to switch off the x-axis and I'm just going to switch on the y. Okay, so what I have done, so I've actually messed this up actually, because where I added the symmetry, it's added it where the cloner is. So maybe that wasn't a wise idea to tell you to do the option. But all we can do is we can just zero that out, because if you saw, I had a value in the position on my symmetry, and therefore the point of symmetry wasn't centered to where my cube is. It was where my cloner was originally. So yeah, if you do that, just make sure you zero that out. And now you can see that symmetry plane is bang in the middle of my cube. And we have what we want. Cool, so switch off my planes. And so now as I move my cloner, you can see that we can create those gaps. But the trouble is now we're not actually creating them. So this is where we need to add our volume builder. And I'm just going to save this so I know, just in case, just in case, you never know. You never know what might happen. So let's grab a volume builder and we're going to throw everything into the volume builder. And we get these big giant squares. And what these are voxels. What the volume builder is doing is it's taking all our geometry, everything that we've just put inside of it. So our clones, our clone cubes, and our main waffle cube. And it's converting it into voxel data. But the trouble is, because my objects are really, really small, so we reduce them down to a real world scale. So our cube is like 10 by 1 by 10. I will need to reduce my voxel size because this is way too high. These are the size of our voxels. We have a 10 centimeter voxel. So if I put this down to 0.1, we can now see we're getting a little bit more of that geometry that we can see. And as I start to move my cloner down, we can see that it's starting to intersect and it's starting to merge. At the moment, this isn't geometry. We need to mesh it to make it geometry. And let's just come back out of there. And now we can see, cool, we're getting somewhere. In my volume builder, what I want to do is I want to subtract my cloned cubes away from my main cube shape. So I just want to go into my symmetry and I can choose the blending mode subtract. And then if we come into our side view, I can take my cloner and we can start to move it down. Cool. Cool, so this is what we have so far. Let me just hide that taper. So we've created those indentations on both sides. So the next step is we want to actually add that outer edge. So I don't know if I can show it on here. So I'm saying real world scale. Sorry, I have a little bit of a cold. So yeah, so real world scale. So what I'm talking about when I say that is the scale of objects in the real world. So what I did was when we created the cube, so in our case, when we're creating this waffle, I'm creating it in the size that it would be ish in the real world. So I'm not going to have like a 1 meter by 1 meter waffle. which would be amazing, but very unlikely in the real world. So yeah, that's what I mean by that. So we have this kind of outer edge here, and that's what we're going to create. Again, really, really nice and simply with another deformer. So if we just grab ourselves a bulge deformer, throw it onto our cube, we're going to fit to parent. And then again, I need to make sure I just increase so we have an extra segment on just the cube. And so now as I begin to add this, we can see that we're getting that little edge there. And if you look at photographs or images of waffles, you'll be able to see that they have that little edge. I don't know whether they make like the top half and therefore they then press them together. That's what it looks like. So that's how we can create that. Cool. Also, Daniel's wondering, am I using Redshift or Octane? I'm using Redshift. At the moment, we're just going to be Cinema 4D focused. If we have time, we'll dive into the Redshift side of things. And the current Mac that I am using is an M1 Max MacBook Pro. So there you go. That's my specs. However, I have just got a new laptop, which I'm going to be talking about and using in live streams very, very soon. I just didn't have enough time to configure it for today's stream. All right, cool. So from here, the next step is just building up some extra detail on this. So another thing I like to do is just to really exaggerate this edge is to duplicate this bottom cube, remove the deformer from it, maybe make it a little bit smaller. So I've decreased the size on the Y and I've increased the size on the X and the Z. I mean, I have this. At the moment, you're thinking it's probably looking a little bit strange, Elly, but it's cool. It's fine because we're going to add some smoothing filters to this and some displacement, which is going to help make this just look a lot better. So let's do that. Inside my volume builder, let's add a SDF Smooth. And straight away, there's too much smoothing going on. So let's reduce the voxel distance. But again, we're still losing too much of this. And this again is down to the voxel size. So again, because we're working with small values, we can get away with making this smaller. It's important to be aware of the size that you're working with, the size of objects. So if I had, for example, a default cube, which was 200 centimeters by 200 centimeters by 200 centimeters, and I threw that into a volume builder, chances are you're not going to want to go down to a voxel size of what I'm using right now, because it would be really, really high res. It would be really kind of like dense when it comes to subdivisions. You'd be able to get away with a larger voxel size. So this is sort of what we have so far. And what I might do, so I'm thinking if I look at my top view, I think there is too small of a gap here. So I might actually just come back in. And again, this is why creating things procedurally, just like this, is really, really useful. So I can come back to my cloner and I can say, okay, let's pull that gap in. Let's go. No. Let's go. Bring that back. And let's go NA on here. Here we go. So we can see everything, all of our geometry a little better. And let's just put this to 7.5 and 7.5. So now I've pulled that in a little bit more without having to make a lot of drastic changes. And then let's actually come into this cube. So this is our outer edge cube. Let's maybe go 10.5 and then 10.5. No, okay, I'm just gonna leave it at that. This is where it's down to your own creativity and just your personal preference as to how you want these waffles to look. So this is where we're at so far. We've got our procedural waffle. The only extra thing I'm going to do is to add some displacement. So what we can do is we can add some displacement to this overall volume setup by just throwing it inside of a null. So by pressing Option G, or you could grab yourself a null, it's like an empty layer, empty group, and throw all your objects inside of it. And then if I want to deform this entire setup, this is what I do. Throw it into the null, and then I'd grab my deformer of choice. So in our case, we're going to displace our geometry. And I'm going to drop my displacer in between the null and my volume measure. So you can see that everything is coming off the null, but the displacer and the volume measure are actually on the same line. And let's go to our displacer. First of all, we'll need to add some shading. So let's add a shader. Let's add a noise shader, and everything's going to go crazy. And that's fine. That's because of our height. So again, because the height is at 10 centimeters, which is the default size, but we're working with smaller objects, we will actually need to pull this down. If we go to 0.2 and come back into our shading and start to pull this down, hopefully you can all see that as I play with the global scale, we can create some displacement on here. So let's maybe go 25. Anything too hectic. And we're now getting a little bit of displacement, a little bit of variation, and that's just going to help sell it a little bit more with the stylized effect. And let's just hide that for now. Okay, so here is our waffle. Another tip you could do, and this is something that I didn't end up doing, is if you want to add more detail, you can layer up your displacement. So we could add a really small scale displacement, just to add like little marks over the top. Or we could add just a second displacer and start to layer up that way. I mean, you can even add fields inside of your volume builder. So let's just like real quick, I'm just going to show you how you can do that. So if we grab a shader field and we drop that inside of our volume builder, and let's put it beneath our SDF Smooth. We can even switch that off now. So inside of our shader field, my creation space by default is set to box, but we want it to be affecting the objects below. So all of the objects want to affect the objects below. And then in my shader field, similar to the displacer, we can add a noise, and you can now see we're getting some noise. But if I pull this right down, let's add let's go 2. What we can do is we can add some extra detail and geometry over the top, which we could then smooth. So this is another little trick if you want to add some effects and add some details, but I'm not going to do that, because what I like to do, or a way of doing it without having to affect the geometry, like in this case, is we do it in the material. And that's my personal preference, my personal choice that I like to do to create more detail and have more control. And that's exactly what I did. Cool. So this is the procedural waffle that we have created. Again, you can go into a lot more detail by adding the displacers, adding the fields, just creating whatever you want to do. But the nice thing about this is at any point I can go back and I can change the sizing, the scaling. I could have it so so instead of having a 5x5 grid of indents, I could have a 4x4 or a 6x6. I could change them to circles if I wanted to. All of that is possible using a procedural setup. Cool. From here, what I'm going to do is have a little look at the topology. The topology are the subdivisions or the segments that make up our geometry. And if I press NB, this should be showing. Okay, never mind. I have like a keystroke thing set up that should be showing the keystrokes, but it's not. But hey, never mind. If I just have a little look in here, we can see the subdivisions or the segments that are making up the topology of our waffle. I've talked about this before on previous streams, because this is the way I like to model. there's a really handy trick and technique that we can use that is going to remesh and retopologize this really, really quickly and really easily for us. And the reason that we want to fix or have cleaner looking topology, and when I say cleaner, I mean we want to have even quads over the whole surface of our model. And there's two main reasons for that when I'm talking about this specific project. So the first reason is when it comes to UV unwrapping, having nice clean topology and having nice edge loops, it's going to allow us to set up our seams, set up our loops, and unwrap far easier than having a uneven topology would. It's also going to help when it comes to simulating. So as we know, when it comes to running simulations inside of C4D, whether it's cloth, balloon, soft bodies, having the amount of subdivisions plays a key part. So if you have a high dense model, it's harder to control, it's less rigid, it might just be slow. And it also will create different types of simulation over our object. And so what we want to do is we want to just remesh this. So I grab my remesh and I want my Z remesher and my mesh density. And I'm going to drop my null into my remesh. Everything's going to go in there. And again, still procedural at this point. We're able to remesh it whilst keeping everything procedural. So while that's doing that, just having a quick look. So Thompson's saying that you're curious about the liquid pour. Yes, we will be there, I promise. Yeah, the plan is to basically finish this off. Then we're going to do a soft body simulation, or we're going to unwrap this quickly just for texturing purposes. Then we're going to do a soft body simulation, and then we're going to get into the liquids and the syrup and all of that fun stuff. Cool. So as you can see, we now have a much more even density or topology going on. And the great thing with working with this remesh is we can actually even reduce our mesh density. So, I mean, how low do we want to go really? Let's see what 40% of the original density looks like. So what it's going to do is it's going to remesh it. So we're still going to get even topology, but it's also going to reduce the overall density or the subdivisions by this amount. So while it's doing that. Hey Dustin, how's it going? It's been a while. It's been a whole 24 hours. Cool. So we have now just remeshed this, and we can see that we still have a whole bunch of the detail. So we could go even lower, actually. We could go even lower. Let's go lower. Because why not? And what we can also do is we can make sure that our subdivisions and our mesh is also symmetrical along our different axes. So we're going to have it symmetrical on the X, Y, and the Z axes, which again is going to help when it comes to creating edge loops and things like that. So what I am going to do is let's have symmetry on just on the Y axis, because I don't want to mess with the displacer too much. And I like the randomness of the displacer. So we have this going on. Again, still have a lot of our detail. And this is where we're at. So we've created our procedural waffle, we've done that, and we've now remeshed it. And at this point, this is where I would then convert this to a polygonal object. And so what I mean by that is I'm going to make it editable, and therefore it's going to be no longer procedural, but I'm still going to have access to this setup. So what I'm going to do is I'm going to make it editable by coming to my remesh. I'm going to right click and go current state to object. And it's going to give me a brand new version, which is just a single polygonal object of this. And then let's just throw this into a new scene. And this is what we have. And the reason for this is is I do actually want to UV unwrap this, or I want to auto unwrap it. And the reason I want to auto unwrap it is because even though I'm going to be doing procedural texturing on this, when you work with things like Maxon noises, they are seen in 3D space. So think of this, the viewport being like a massive cube with the Maxon noise pattern all inside of it. And if I put my, you know what, let's kind of view it. Let's see if we can view it as much as we can. Let's just grab that and we can just X-ray that. Okay, cool. So think of this cube as being the Maxon noise. Different parts of this cube are going to have different parts of that noise algorithm in. And so what that means is, dependent on where my object is, so in our case, the waffle, where this is inside of this 3D noise, I'm going to get a different look. And that doesn't matter if we're keeping things still. If we're creating a still image and it's all fine, then it doesn't matter because our objects aren't going to be moving through that pattern. But if we create an animation, which in our case we're about to do, and we have our waffles falling down, it's going to be falling through that Maxon noise. Therefore, that pattern is going to change as it comes down. So how can we prevent that? That's what the purpose of UVing is going to be. We're just going to do a very quick auto unwrap, and this is going to stick the Maxon noise texture to it. It's going to solve all of our problems. So let's go to save, because I came across a bug earlier. There's a little bit of a bug when you go to the UV edit mode. Sometimes it can cause a little crash. So just in case, I'm going to hit save. So I'm going to remove my UV tag because I'm going to reset these up myself. We're going to go to the UV edit mode, and I'm just going to click set UV from projection, and then we're going to apply some packed UVs. And okay, that is looking not as nice as it did earlier. Okay, I mean, that's not that bad, but let's go to the one I did earlier, which was this one, which is the exact same setup, strangely enough. Let's put that into here. And then let's just get rid of that. And let's see what our pact does here. Okay, cool, that's a little better. All right, cool, so let's come back into here. Let's get rid of that. And let's hope that I called it. All right, yep. This is the bug I came across earlier. Let's just reopen that. I don't know. It has now since been reported. I'm not sure what's causing it. I'm very sorry. But let me just reopen that and have a little look. Let's get this back open. These things happen. And this won't go away now, which is cool. Right. Let's get back into the procedural waffle. Reopen that, repaste that, and let's try that again. Set UV from projection, packet. Let's just save that as 0002. And pray this comes back. Yeah, see, I don't know why sometimes it does it and sometimes it doesn't, because I just did the exact same thing and now it's fine. So cool. So we have our quick UVs that we've just set up there. Now let's go into, yeah, so so just to reply to Daniel's comment, yeah, it's a current bug. That's why it's crashed. It's just a little bug with the UV editor. I'm not sure what causes it, but hopefully it should be fixed soon because it's officially been reported today. Right, let me just move that little error out of the way. And let's look at creating a soft body simulation now with these. We'll create a little waffle soft body. Right, so let's call this waffle high. And we're going to go and save that. And let's just set up our floor. So we're going to set up our collider. And let's lift our waffle up. Okay, so what I'm going to do is for this, I actually ended up using a mesh deformer. And the reason is because this isn't like super high poly, right? It's not super high poly. The thing is, if I simulated this now, it's just going to collapse in on itself. And you know what? Let's do it. Instead of me talking about it, let me just show you. So let's just throw a simulation collider, and then we can throw a cloth tag on here. And before I do this, I'm just going to go to Command D, and that's going to give me my project settings. And if we go to simulation, inside of the scene, this is a really important step. So if you're working with small sized objects, which in our case we are, it's a 10 by 1.5 by 10 centimeter cube / waffle. We want to adjust our scene scale to tell Cinema 4D, okay, when it comes to simulating, this is the rough size of our objects that are being simulated. And at the moment, 100 centimeters is way too big. So if we just change this to 10 centimeters, we're now going to have some more accurate behavior. And Cinema 4D and the simulation settings and the physics are all going to understand that we're working with objects roughly of a scale of 10 centimeters. So now if we just press play, the first time I press play, the first time it tries to simulate, it will take a little bit longer. But once it's done it for the first time, it will then stop. Okay, cool. So, we can all agree it's not really looking much like a waffle anymore. It's just collapsed in on itself. And that's because we set up a cloth simulation, and also because we have quite a large number of segments going on. Well, it's not like a huge number, but it's enough for it to just collapse in on itself, because the cloth settings like bendiness and stretchiness are all determined on the number of points that you have. The more points, the more, if we're picturing cloth, if we have a nice plane that's got a lot of subdivisions on it, the more of that smooth cloth-like motion you're going to get, because you're going to get more bendiness and stretchiness occurring. In our case, we want the complete opposite of that. We don't want any bendiness. We don't want any stretchiness. We don't want it to collapse in on itself. We want it to keep a lot of its rigidity. But the thing is, we don't have a rigid body sim. We have the bullet dynamics going on, but we want rigidity, but we also kind of want softness. So if we think of the way that the waffles would fall onto each other, they would have a little bit of that softness and that squidginess, but they're going to keep their shape. So we want the best of both worlds. How do we create the best of both worlds? Well, we can actually take advantage. Let me just get rid of that for now. We can take advantage of the mesh deformer. Let's just go option 0, pull that back into its original area, hide the plane for now, and come back into our procedural waffle. So this is where keeping all of this stuff to hand is super handy. And I'm going to grab the original cube. So let's just paste that in there. And so now we have the original cube, which we can see is roughly the same kind of size and shape. And the reason that this is useful is we can now simulate this, and then we can use a mesh deformer. So let's actually go waffle low, pull that into there. I'm going to group all of this. So option G, and this is like our waffle group. And we're going to grab our plane. So let's pull this up. And then how many waffles do we want? Should we do 3 or should we do 4? Let's do 3. Oh, let's do 4. 4. Cool. So this is what we have. And then let's just add some rotation going on. So I'm going to pull each of them up, and this is going to be our falling simulation. So let's just grab each of these, pull it up. And what I'm doing is I'm grabbing everything together. So I'm grabbing the low res version and I'm grabbing the high res version as well. And this is sort of what we have. This is what we have going on so far. And let me just grab everything and let's pull everything up to something like this. Okay. Cool. Now what we want to do is we want to simulate the low resolution waffles. So let's just hide all of these high res waffles because we're not fussed about them at the moment. We don't need them. Let's get rid of them. And we just want to go with these low res versions. And so as we know, or as we saw there, when it comes to simulating high res objects or models, because of the way that the cloth settings work, even if we combine it with Softbody, which we're going to do, it's not going to be able to keep enough of its rigidity for it to look like a waffle simulation. And so this is the important thing. I'm talking about simulating a waffle here when I'm talking. And so we want it to keep some of its shape. We want a little bit of maybe some bendiness and some softness going on. But again, we don't want it to collapse in on itself. So if I just come to my low res waffles, I can just choose some segments that I know are going to still enable it to stay a little bit more rigid, but also still create a little bit of like cool looking simulation. So let's just do 8x8 for now. And then let's go back to that. And then let's throw a cloth tag on each of them. We don't want any bendiness, any stretchiness. We do want to have quite a high amount of friction because as they come down, we don't want them to be sliding along each other. That's not ideal. And then we do want to reduce our thickness as well. Okay. Let's just save that. And then let's go back to our plane, which also needs to have our collider back on it. And then let's see what this looks like. Okay. Okay, cool. So yeah, not really what not what we're hoping for, but we're at a better starting point than we were before. And as you can see, it's really fast because we're running with low res models. So let's go to Command D and let's go into our simulation. And here is where we can really start to dial in a few of the issues that we have. So first of all, we're getting a lot of collisions. We're getting a lot of things intersecting, and that is all down to our collision passes. And it's also because of the thickness that we changed. We put that to quite a low number. And so we need to make sure that we increase our collision passes to prevent any collisions from occurring. So we're still getting some, but what we can also do is if we go back into here, we can start to increase our substeps. Substeps can also work really well to increase the rigidity of your simulations. So think of them that way. So when it comes, if you're working with a really nice smooth cloth simulation, you don't want to up your substeps too much because it will actually counteract some of the bendiness and the stretchiness that you've set up. Maybe we can go and increase our substeps. And now we can see that we've fixed any of those collision problems from happening. Another thing we can do is I'm a big fan of this damping at the moment, especially in this case, because I want to soften or dampen some of the energy or the speed at which everything is coming down. We can actually start to play around with this value in here. Think of this like if you go over a value of, I think like they say in the documentation, like 5% or maybe 10%, it's going to start to look like things are simulated underwater. That's what it says. And that's a really great explanation. But for this, because we're creating a stylized animation, Dustin, if you're still here, stylized, I'm running with it. And so as I pull this down, you can see that it's softened or dampened a lot of that animation. And now we're getting a lot closer to a more accurate simulation. Another thing you can do, if you see you get this little wobble effect happening in this movement, we can increase our smoothing iterations as well. And that's just going to help with that. Okay. So what we haven't done is we haven't actually changed this into a soft body simulation yet. At the moment, it's still a cloth sim, which actually it doesn't look too bad. It's working pretty well. So if you're happy with that, then by all means, then run with it. But let's actually dive into our soft body. So at the moment, we have a cloth tag. So we can see it's represented by a little t-shirt. But if I enable soft body, it's going to turn into a jellyfish. And we see a few things. We now see these pink lines. These pink lines are called poles. Poles are going to help keep, again, the overall shape between each of your points, whilst also allowing it to add an element of softness to it. So let's see what this looks like now. So I don't actually like them being drawn. So let me just switch that off. And so we have this. And what we can do, remember, we can always go back. And if we find that, you know what, it's a little bit too rigid, we can still come back into here and we can increase the segments, which again is going to work to add a little bit more softness to it. So this is what we've created. So maybe we can do let's do a 10 by 10. This is what we have. So we now have a little bit of that bend. Maybe I will, let's rotate these a little bit. And I'm making sure that I do this on the main group, so on the null, because I want to make sure that the high res version is still matching, because this is going to be really important very soon. I'll play that through. And this is sort of what we have. And it's actually looking not too bad. So play around with those settings, play around and find some settings that you're happy with. Remember that you're working with the low res version and you're simulating the low res version. In your simulation settings, one of the most important things is this scene scale. And then inside of my simulation settings, collision passes are key to prevent a lot of those initial intersections, especially when you're working with small objects and a small thickness. Substeps are going to, again, help prevent some of those collisions and some of those like errors that you could come across. But they're also going to help work to create extra rigidity. So Daniel, that was for you, because I know you wanted me to say rigidity again. Yes, and then smoothing iterations can work to prevent that jiggliness, and the dampening will work to remove or take some of the energy out of the simulation. So play around with all of those different settings. And remember, in your cloth tag, the chances are, if your aim is to create, let's say, a soft, rigid body sim, you don't really want bendiness and you don't really want stretchiness, because that's just going to cause more issues between the points. So bendiness is the amount that the points are able to bend between each other. The less bendiness, the more rigid it's going to be. Stretchiness is every other point. It's how much of a stretch distance it can have. So again, isn't going to work in our case. And then the friction was fine. And the last thing I would do is always do a little bit of friction on the floor, so we don't have like a slidey effect going on. Okay, so this is where the magic happens. You're probably thinking, but Ellie, they're still super low res. And I'd agree with you. So let me just grab that. From this point, this is where we can now take this simulation, take what we've just done, and we can apply it to the high res waffles. I know. So let's bring back our high-res waffles, which as you can see are still in the same shape. And they're the same rough size. That's really important. We can't just do any old shape or any old size thing and have it match our objects. It has to be roughly the same size. Because if it wasn't and collisions happen, and let's say the high res ones have more of a gap between them, it's still going to simulate the low res. So we're still going to see a gap. So other issues can just occur. So let's go back to our trusty old deformers and let's grab a mesh deformer and then let's just copy and paste that a few times. So we're going to put our mesh deformer on our high res waffle. This is important. Drop a mesh deformer on each high resolution waffle. And then in the mesh deformer, it's going to ask for a couple of things. Let's just pull this up. It's going to ask for a cage. The cage is going to be our low res waffle. And then we can set external to surface. This means if there are any polygons in the same area, so the low res and the high res, if there is any kind of minor differences in their size and shape, which in our case, there are some minor differences, it's going to resolve that. And then we're going to go to initialize. And then what we want to do is just this for each of them. So we're going to go surface, drop our cage in and initialize. And then we're going to go to that, drop our surface in and initialize. And then just on the final one, let's just throw in our low res cage, go to surface and go to initialize. Now let's hide our low res. Hide the low res. And then press play. And now we can see we have that on our high res waffles. So we've used the low res to create that, and then it's looking pretty cool. Looking pretty cool. So you're probably thinking like all of these problems that we have going on here, that's fine. We can fix all that with tessellation and subdivisions later on. It was just because I remeshed it a little bit too low, but that's not the end of the world. So this is the Softbody simulation that we have set up. We've created this, and now what we're going to do is we're going to bake this as an alembic because I want to create the liquid, the syrup, the reason I'm sure you're all here, like the good stuff. So let's just save that. And what do we want to do? We could just bake that as an alembic, really, couldn't we? So let's go to File. You can bake individual objects as alembics. You can bake them down, or we can actually go to File, Export, and we can export the whole thing as an alembic. So let's just save that. And depending on how high res everything is, depending on how many frames are in your scene, will be how long that's going to take. Then what we can do, we can find that, which is in here somewhere. I can drag and drop that into here and everything's fine as default, and we can just throw that in. And so you can see what we've got is we've actually got everything. So it probably would have been a little bit better of me just to have baked the high resolution waffles, but no problem. We can just take them out of here. We can keep the plane. We don't really need the plane. Grab everything else and get rid of it. And then now we have our simulation in here. So if I just click one of these, we get our Alembic data. And one thing that I do like to do is there are some slight animation options that we can do. So if you find that this animation, let's say you've baked it and you've done it and you think, oh, it's too fast because I wasn't able to see it in real time and now I'm unsure. Well, we can come back and we can actually adjust our playback speed. And so now we can see that we're getting a slower animation just from all of this Alembic data. And another quick thing I want to show you, this is thanks to Jonas Pilz, who showed me this morning, is that at the moment, I can't actually do any sort of polygon selections or edge loops or anything like that on this Alembic data. But if you actually make it editable, you still have access to all the Alembic information, but you then have the ability to then do your polygon selections or your edge loops and everything like that. So that is another useful trick. Okay, so let's get to the liquid, shall we? Because I know that's the good stuff that you're all wanting. So for this, what I am going to do is I'm actually just going to again convert this to a single still state. So I'm going to set current state to object, and we're just going to work with static waffles, just so we don't have any issues. But it's a stream, and I want to try and keep it as fast as possible. So let me just go right click and current state to object, and then objects and delete. So this is what we have. And let's just get rid of everything else. Oh, we could have had the plane. Let's just throw the plane back in. Okay, and then let's just do a subdivision surface for the waffles. And then you'll see that that is actually just going to fix some of those problems. We can now see we have a nice smooth waffle. Cool. So let's create this. Let's create this. I'm just having a quick look through any of the questions. I think we're all good. Again, I sort of said this at the beginning, but if anyone's joined partway through, if you have a question for me, let me know in the chat. But do me a quick favor, just add the word question in caps at the start, just because I'm sort of monitoring this by myself and it helps me out. So thanks. Okay, right. Let's get to some liquid. So again, I did a disclaimer at the beginning that this is not a great like be all and end all liquid technique. This is just a trick that I came across with the help of the rest of the team because I wanted to try and create some interesting looking animated liquid. This is the important thing. I wanted it to be animated because there are tricks that we can do when it comes to stills with sculpting, but the animated side of things is really where we want to be. So in case anyone has joined later on, let me just show you. Let me show you this. So this is kind of what we're going to be recreating. This is the aim. This is the aim. So let's get into it. Let's get into what we want to be doing. And again, let me just come into my simulation settings. So this is important because I'm in a brand new scene. I do want to make sure that I reduce my scene scale again. And let's go to save this and let's just go to 003. Okay, right. So the way that I did this was I thought about how did I want the liquid to fall? And you're probably thinking, why does this matter? Well, it does have a part to play. Because we don't have I'm not going to be working with any kind of like liquid simulator or any kind of like particle system, which is what you would really need in order to create these really beautiful looking sims. I'm going to be working with geometry, converting it to cloth geometry. So we're going to be working with a cloth sim, and that's going to work inside of a volume builder. And so the way that I wanted it to look like the syrup or the liquid in our case was being poured over the waffles in a circular fashion. So you have to think, okay, what shape do I need? What shape geometry or spline do I need to ensure that movement? And so that's the first thing that I thought of. And I thought, well, what better way to create that than by using a helix? So let's reduce my helix right down. And let's just sort of like make it small. Let's pull it up. So this is also where our liquid is going to start from. Let's maybe pull this up a little bit and let's just take a little look in here. And we want to make it a little bit bigger maybe. And let's just increase our height. So maybe we go 12. And then we want to have no start radius. So this little bit in here is going to come into the middle. And then we can add not a radial bias, an end angle. This is what we want. Let's do about 1,000. Okay, so at any point we can change this. We can change this shape. We can change the thickness of our syrup. So that's not, I'm not fussed about that at this point. I just want to start to create the shape. And the way that we can convert a spline into geometry is by using a sweep. So let's take a sweep and then let's grab a circle. And then let's go 0.1. And just drop everything inside. 1. No, definitely way too big. Okay. So we're sort of getting there. This is going to be the geometry of our liquid, and it's all going to make sense when we start to add the cloths in. So let's go 0.4, make this a little bit smaller. And then inside the circle, we want to keep it as low res as possible. So my intermediate points, let's go to 2, and let's go to 2. Okay. So the next step, before we actually set up our cloth sim, I mean, we could set up our cloth sim first, is we're going to set up a vertex map on here, because what we want to do, we want to create a vertex map growth where the vertex weight starts at the bottom and then it grows over the top. And then what we can do is we can use that inside of our cloth tag to control at what stage the geometry turns into a cloth sim. And so that's going to prevent the entire thing from just falling. So on my sweep, I can right click and I can grab a vertex map. And then we can just grab a spherical field. My spherical field is going to allow me to really position where this growth is going to be. And quick little side note here. If you want to animate this on, you absolutely can do. So if you don't want your cloth sim to start at the absolute beginning, you could animate this spherical field on, and then you could have your waffle simulation soft bodies coming down first, and then you could have the syrup animating after. But for this, we're just going to start. So let's maybe go right on the end here. Right on the end. And then we're going to throw on a freeze. And the freeze we can set to grow, and this is going to create a growth over the top. Just play this. Okay, and let's just add some frames. Okay, cool. So we have that. We've set up our growth, and we're going to use this to control where when our cloth comes into play. So if we right click and we throw a cloth tag on the sweep, if I press play, straight away it all just turns into a sim. And let's actually just throw a collider on here first of all. Collider. And it falls through. Right. So let's combine this cloth with the vertex map. So inside of my sweep, we have an option titled Mix Animation. And the way this works is we can actually use this vertex map to hold everything in place that is a value, the red value, so a vertex weight of 0. And as the vertex weight grows and the yellow part grows over our geometry, it is going to be not held in place with the pins of mixed animation. So you have with pins. With pins means everything that isn't affected by the vertex map will be held completely in place. With force is similar to the previous follow position, follow rotation, where it holds everything together, but it's not 100% holding it in place. There might be elements of movement. So in our case, we don't want any movement. So we're just going to drop our vertex map inside of here. So now as I press play, we can sort of see that this is starting to fall down. Okay, so it's not looking great at the moment. And so at this point, it then comes down to tweaking and perfecting the cloth and the simulation settings. And I will say that I spent quite a large amount of time tweaking and playing around and seeing what would work to help. The things that I found most beneficial were stretchiness. So the stretchiness is going to give that effect that the syrup is sort of is stretching and coming down. And the interesting thing of that is because we are creating it this way and then putting it into a volume builder, it's not going to look like the geometry is stretching. It's just going to look like it's being poured. So if we go to something like a friction of 100, a friction of 10 and maybe a stretchiness of 100, we will adjust the thickness at some point. Let's just have a look at this. Okay, so it's starting to get there. Again, we want to adjust our thickness, so then it's really important to come in and ensure our collision passes and our substeps are going to support that. I also found adding dampening on this as well worked to help soften the look. So again, I'm not overly fussed about this looking like liquid because there's some tricks that we're going to do next. All I'm focusing on is I want it to look like we're getting the right kind of movement, the right animation. So the focus on this bit is to ensure that the animation is looking syrup-like. Again, disclaimer, it's not going to be perfect liquids, but we're looking for like a stylized, good enough effect. And so that's the focus here. I'm not fussed that it's currently looking low res or not ideal, because that stuff we can fix at the next stage in here. Also, let's just kind of see if we can prevent some of that. Yes. So one thing I did notice, and I don't know why this is, but when I was playing around with this trick and this technique, I found that I was getting a lot of jittering. So I don't know if those of you who have played around with some of the simulation settings, you may find that we get this extra movement afterwards, and it's not ideal, and it doesn't work well for certain things. And it definitely was having an effect here. I was finding when I was baking it as an Alembic, we were getting some extra jittering because I was seeing it in real time. And smoothing iterations really fixes that problem. Like that really fixed it, as did the dampening. So maybe I can go up to the dampening again. And we can sort of pull this in. So the smoothing iterations will slightly slow it down in the viewport. But again, it's about finding the look that I was after. And so I know that this fixes it. So this is where we're at. We're getting this relatively okay looking pour, and we may even like add some caps. The caps might help add a little bit more. Maybe we go like 0.5. It looks a little bit better in there. Then from here, again, I was then thinking about, okay, now what can I do to the geometry to give me the best possible look or control when it comes to poured syrup? And I was thinking, well, it wouldn't all be the same thickness. We'd have varying thicknesses. Like the first bit you pour could be like a big, like, what would you call it? Like gloop, a big gloop of syrup. I don't know. And then you'd have some thinner areas. So this is where we could, again, just do some quick tricks with the displacer and just throw a displacer inside of here. Maybe we can reduce that height and then throw in a noise. Let's maybe go 30 and let's just increase that height to 0.3, maybe 0.4. So I want this to look like we've got some thin areas and some thick areas. So maybe something a bit like that. And then maybe we can reduce that a little bit more. Okay, yeah, okay, we're getting there. We're getting there. Let's sort of let's go with that. Let's leave it like that for now. But again, this is what I was thinking. I was thinking, okay, we get some thin areas, some thick areas. So as it comes down, we're getting that randomness, we're getting that variation, and we're getting that build-up of slightly bigger areas of syrup or liquid in this case, which again is going to just help sell it a little bit better, a little bit more. And then at this point, I then threw it into a subdivision surface just to give us some more geometry. Okay, so maybe, do I want it to be a little bit bigger actually? Let's maybe have a look. Maybe a little bit less. This is where I can just sit and play. I can sit and just tweak this forever, but I don't want to do that. I don't want to do that. Okay, let's leave it at that. Let's leave it at that. And what I'm going to do, I'm going to bake this again as an alembic. And the reason for that is the next step involves us putting it into a volume builder. And so as much as I like to keep things procedural, I'm also thinking about performance and speed. And so let's just set this, bake this as an alembic. And again, this might take, depending on how many frames you got and depending on how much subdivisions you have going on, this might take a certain period of time. I've got about 180 frames and it's been subdivided. So just for that, I can have a little look through some of the settings. So yeah, Ron was saying it's an interesting alternative to using XP. So yeah, it's definitely not an alternative to what X Particles is incredible, and I've played with it quite a lot, and what you can do in it is incredible. But this came about from me wanting to try create some kind of interesting animated liquid effect. And so that's sort of the idea behind here. In no way am I sort of saying that this is a perfect method, but it's quite interesting. And this isn't the finished version. So once the alembic is baked, I'll bring that into another scene and I'll show you how we can then add even more kind of tools and techniques to add to this a little bit more in there. And then Daniel was wondering, I mean, you might have to get the chat to answer this question for you. Which came first, the chicken or the egg? I mean, that's the age-old question, right? I definitely am not qualified to answer that. Also, hey to Tricky Pixels. How's it going? Hey from Ireland. Cool. So we're nearly done with that. And so let's have a quick look. If you have any other questions for me, then absolutely just let me know. Sibel was wondering, the volume builder is so heavy. I wonder why I'm not using the Boolean. So I imagine this was back to when I was creating the procedural waffles. The reason I like the volume builder is there's many different reasons. The blending modes that you can create between them, the easy ways of adding and removing and subtracting different things. We have different smoothing layers and filters, for example, Dialte and Erode, that you just don't have the same amount of control when you're working with a Boolean. And that's also why if I'm doing volume builder modeling, I then remesh it. Because again, yeah, it completely gets rid of a lot of that maybe not so nice topology, and we're able to go a little bit lower res, and then I convert that to a polygonal object. And so that's just my method. And so then once I've got that remeshed polygonal object, it's no longer heavy, and I bring that into a new scene. And that's sort of what we did here. So that's my process. That's just something that the way that I like to work. Okay, cool. We've got our alembic. Rambled my way through that. And here we go. Cool. Let's get that. And let's take our waffles and let's have a little look. We can even switch that on. So this is what we have. Let's go 180 because that was what we had before. So we have this so far. We have our cloth geometry, which is looking sort of liquidy. But the trouble is we now want to actually make this look a little bit more like syrup. I want to see how can we control this a little bit more? Well, we can grab a volume builder, drop our Alembic into our volume builder, and again, let's just drop our voxel size down. So let's play this through actually a little bit. So let's go, what's a good look? Maybe something like that. And then we're going to put that into a volume mesher. And let's just save this. Way too many zeros, but hey. And then maybe we can go a little bit lower. Let's see if we can go, how low can we go? Let's reduce that down to that. And then we can throw in a different filter. So we can grab what's called a dilate and erode. And a dilate and erode is going to allow us to offset the mesh by a certain centimeters. So at the moment, 5 centimeters is way too much. But if I offset it by 0.3, what you can see is we're almost adding more geometry. So we're just creating a more liquid or a more built up looking syrup. And as everything is sort of coming together, it's merging and it's combining. Then from here, we could add a smoothing filter. So we could add iterations for that. I mean, we could even, what could we do? 0.25 maybe? And so now we're creating this build-up effect. And we could continue to do more. We can continue to do more smoothing. I don't know how fast this is going to be because, as you said, yeah, the volume builder can be quite heavy, especially when it comes to a lot of smoothing effects or filters. This is sort of what we've been able to create. And this is exactly how I created that syrup effect. The only other thing I did do, so let's talk about this like real quick. So because the dilate and erode, it's offsetting that mesh and it's creating a thicker mesh. Now the pour, so the line that we have pouring down, is actually probably a little bit too thick. So what we can do is we can grab another, let me just switch off my smooth. We can grab, let me just sort of like come through maybe somewhere like here. We can grab another dilate and erode, do a negative 0.1 or a negative 0.2 maybe. So we get back to almost, I mean, we could do the original. We could do a negative 0.25 and then we get to the original size. And then we can use a field so it doesn't affect anything that is then on the waffle because we want to keep this the thicker value. So let's go into the fields of the second dilate and erode, grab a linear field. Let's position this on the y-axis, and then maybe we can go to 1 centimeter. And let's just pull this up. Here we go, 0.5. Cool, so now we've got the thicker built up area, but then we also have this thin line still. We can bring our smooth back on. And so now as it comes down, it's going to, that dilate and erode is going to kick in and it's going to make it look like a nice thicker syrup. Again, we can also actually, if you find your volume builder is really heavy and you're done making changes to it, you can actually cache it and you can cache your volume builder, which again will be a little bit less heavy. So this is the way that I created, again, just to do a quick reminder of the final animated version. This is the exact setup for this. It's using the Helix, the sweep, and the circle with a cloth simulation on it. And then that was set up with a variety of bendiness, but most importantly, the stretchiness with a little bit of dampening. and that was baked as an Alembic, and I brought it in and then just used a combination of the different filter effects to create it to look a little bit more like liquid. And what I did find, and this might just be my personal thoughts on this, but because we're going to add, or because I then did add a liquid material to this, because it has subsurface scattering and it has translucency elements of that, you can kind of get away with more. And that is also what I find helps sell it and helps make it look a lot more like liquid. And so even though the movement is a little bit off, that helps to kind of sell it to look more like a liquid simulation. Okay, so I'm just sort of keeping it on the time. And again, I didn't think I would really get round to doing all of the lighting and the texturing, but there are a few links that I'm going to put in the chat that's going to help that. And again, in case you join later on, I'm going to supply the full final version as a project file. What I'll do is I'll link it in the description on the YouTube video. And I think that'll be probably Thursday, because I need to tweak it a little bit tomorrow, take some of the resources out that I'm not actually allowed to share, but I'll replace them with some good ones. So that's going to have all the lighting, all the texturing, and all the setup. And just to talk a quick bit about it, so let's see if I can find the final scene. As you can see, my naming is and my organization is pretty shocking. But let's open this one here and see what we got. Okay, yeah. So this was the original one that I did, the original still, which actually looked like this. Yeah, and if we go into our render view, I can just show you this a little bit. So this is the scene that you're going to get, or you can have the other one, which is the one with like the black bowl and the wooden side, which is that one. I'll throw both on there. That's not a problem. But just to quickly talk about the lighting and the texturing that I did on this, let me just get rid of material override. So the texturing and the lighting on this, let's talk a quick bit about that. So the texturing, I'm just going to link something in the chat for you all. The texturing was all done procedurally. And by that, I mean it was using Maxon noises or texture maps inside of a color layer to create this type of material. And so here is a stream that I did, which runs through how you can create procedural materials inside of Redshift. And then the lighting side of things, if you weren't part of Monday's demystifying session with Nick and Dustin Valkamar, who was actually earlier, he was in the chat earlier. He might not be here anymore, but I'm absolutely going to plug him because he's an incredible photographer, concept artist, and just overall master trainer in Cinema 4D. And the knowledge he has on lighting is exceptional. And so on Monday's session, he went through how he would light a shoe that Nick had created and textured. And so if you want to dive into some lighting techniques, definitely check that out. I would say from about the 40th minute mark, that's when he goes into all the different lighting techniques. And it's exactly the same sort of like techniques here that I would use. Ambient lighting with a dome light and a HDRI, that's always my go-to. And then a couple of little area lights. That's as sort of advanced as this got. I can even show you. I can even sort of come out and show you all. It is my cameras, my bounce card. Where is my lighting? Area light, dome light. So definitely, I would really recommend checking those out. But again, as I said, I'm going to make this whole project file available, and all of the extra little bits in here are just models from the asset browser. So definitely check out the asset browser asset browser. If you haven't, I said that very weirdly. We have a whole bunch of models that you can use in your scene. So the strawberries, this is actually just a plane with a texture on, and then this is a plate. And also, people ask me all the time, because I'm a real advocate for Redshift, and I love to talk about it pretty much all the time. People go, when are we going to get some Redshift materials in the asset browser? Well, if you search Redshift and you go to materials, honestly, I went through some of these today because my plan was I was thinking I might run through it later, but I don't like running past the hour and a half mark. Like I'm sure you've all got things to do and you don't need to listen to me go on and on all day. But here are some great, these are all Redshift textures. You can tell because they have the little Redshift mark here. And we have so many really beautiful looking materials, and more get added each month. Those of you who have like subs to Maxon One will know. And so the syrup is actually, I just edited the liquid honey a little bit. I played with that, I messed with that. If you do want to know, let me know. I'm sure I can do like another tutorial stream on it. But yeah, loads of really incredible materials and textures that you can just drag and drop in, change some of the colors and throw them on to create a really beautiful looking shot. Cool. So yeah, I guess we can kind of round it up there. If anyone has any final questions, then please do let me know. I hope you've enjoyed sort of diving into a variety of different aspects. Just to do a very quick recap for anyone who's joined a little bit later on and is thinking that they might watch this again or want to have a little recap. The starting point was we created procedural waffles inside of Cinema 4D. So if we come back into here, we created this procedural waffle element. We remeshed it using the remesher. And then we created a softbody simulation. So is this going to, yep. So we then created our softbody simulation using the mesh deformer. So we looked at a couple of different tricks to keep the high res version, but by simulating a low res version, we can keep the rigidity a little bit more. It's also going to be a lot faster. We then baked things as alembics, baked them down, and then looked at how we can adjust the speed of them, which is quite a cool little trick. And then we looked at this liquid syrup simulation and how we can create this kind of thing inside of Cinema 4D using the new amazing cloth sim things here. And also we threw that inside of a volume builder. So that was a quick little recap. I hope you guys enjoyed that breakdown. I'm really sorry that I didn't get to the Redshift side of things, but again, it's similar things that we've talked about before. So again, definitely check out that demystifying session from Dustin. I think it's only maybe like 20-30 minutes where he talks about it, but it's such vital information. Like I can't express that enough. He's exceptional, and it's very easy to kind of understand and to pick up. So if you incorporate that into this shot, it's going to just look really even more tasty. And then the live project breakdown that I sent, which was a stream on procedural materials, that will help you to texture this. And then very soon I'm going to be doing another stream on optimizing render settings. So I know we all want faster renders, and I keep promising this. So I'm absolutely going to be doing that soon. So yeah, maybe we can incorporate this into that, and I can show you how we can speed up the render times for this. But that being said, if there's no more questions, which I don't think there are, thank you so much, Hannah. I'm really glad you enjoyed it, and I hope the rest of you enjoyed it. Yeah, have a good one. Have a good rest of your Tuesday, whether it is the morning, the afternoon, or the evening. And I'm sure I will catch you on another session soon. Yeah, it's been a pleasure, and I'll see you all very soon. Bye, everyone.